Welcome to the block revolution. Today we will build a Flutter dAPP with vscode. You will learn how to install the crypto wallet and gateway to blockchain apps, MetaMask. We will program a smart contract in Solidity using the Remix IDE. We will also use a Web3 backend and infrastructure as a service provider called Infura. By the end of this video, you will have built a basic dAPP that allows you to make transactions and queries to the Ethereum blockchain. Let's get started. The first thing we have to do is install MetaMask. So go to the website, go to metamask.io and install, make the download. For me it's Chrome, so install MetaMask on Chrome. Add to Chrome, add extension. The extension was added to Chrome. Let's create a wallet. You'll choose your password. Your secret recovery phrase makes it easy to backup and restore your account. You should read all of this. Click here to reveal. You should save your secret recovery phrase in the safe place. Okay, it's done. Your seed phrase is now called your secret recovery phrase. Okay, we will not be using this. When developing, you should always use some sort of test network. We'll choose Rinkaby. Everything is fine, but we don't have any ETH in our account. Let us take care of that. So for deploying smart contracts on the Ethereum network, we need to pay gas fee to the network. Gas is the unit that measures the amount of computational effort required to execute specific operations on the network. So even if we are testing, we need the gas fee to deploy the contract. But we will not be using real ETH. We'll just instead request test ETH for our dAPP. We will click on buy. What we want is to use a test faucet, get Ether. So crypto faucets are websites and mobile applications that will give us a certain amount of cryptocurrency in exchange for doing a task. So for having a free test Ether, we need to request it either on Twitter or Facebook. We'll make a tweet with the Ethereum address for our MetaMask. I'll copy the tweet URL. We'll just paste the tweet. So at the point I am recording this video, it seems like the Rinkaby faucet is not working. So I checked the Open Zeppelin forum, and it seems like a lot of people is having the same problem. So I decided to recover my other account. I hope the problem is solved when you watch this video. So let's continue. Let's now create our smart contract. Head over to Remix IDE. In our file explorers, we will create new file. Let's call it first coin. As you might already know, the first thing we should have in our contract is this SPDX license identifier. Next, we'll add our pragma declaration. We should be a bit more specific than this, but let's just keep it this way. So our contract is called first coin. We'll have a state variable balance. We'll have a constructor that sets our balance to 0. Then we will create 3 functions. One for making a deposit, the second a withdrawal, and the third to get the balance. In this function, the only thing we are doing is we are passing an amount. Then we will create the last function. But before that, notice that we are requiring, before we take the amount from the balance, we require that the balance is bigger than the amount. If not, the transaction will reverse and we will get this error message. So this function is public, is view, because it won't need any gas and it will return an assigned integer. It returns the balance. Now that we have our contract, let's first compile it, see if there are any mistakes. Everything seems to be fine. Before deploying it in our environment, we'll choose injected Web3, and this is automatically recognize our Ring-B network from MetaMask. We will have to confirm it there, and then we will have our account in here, our address, make the deployment. Now we have to confirm it. As you might have heard, it's done. Let's check our contract and interact with it. Let's just deposit 20 first coin. Just confirm on MetaMask. Done. Well, if you wonder why it's happening so fast, as you might guess, I'm editing the video. This process takes a bit of time. Be patient. Send first coin. Confirm the transaction. Done. Now if we check our balance down here, we will have 10 first coin. Well, makes sense. So this is it. Our contract is ready. Let's start working with Flutter. Before that, there's something really important we have to do, so let's do it. So we are going to build a Flutter app with a pretty simple UI to let us interact with our smart contract. And before we do that, we need to set up an API that will handle the requests to interact with the smart contract. We could use Ganache, but we will be using Infura. What is Infura? Infura provides the tools and infrastructure that allow developers to easily take their blockchain implications from testing to scale deployment with simple, reliable access to Ethereum and IPFS. If you don't have an account, you should sign up. It's a pretty standard sign up process, so just go through it. I already have my account, so I will sign in, create a new project, give it a name. I'll call it basic dAPP 2, and then we are sent to the settings, and in here we have our project ID, our project secret key. As always, you shouldn't be showing this to anyone, but this is just for testing purposes. Select the Ring-B network, and this is the information we will be using in our app. Let's go to vscode now. Go to whatever folder you want to create the project in. Create our Flutter project. I'm using 2 underscores because I already have the finished project with the same name. Let's create a new one. We go to the folder and let's open vscode. Here we have our project. We will just start by importing the dependencies, packages created by other developers, and this will allow us to quickly build our app. After removing all the comments, or most of the comments, I will add the dependencies. So we will be using flutter.env to just not place our keys directly in our code. We will have a specific file for the more sensible information. We will use Flutter Riverpod, HTTP, Syncfusion, Flutter slider for the only slider in our app, Web3, Dart for interacting with the blockchain. I will talk a bit about them while coding, but if you want to learn more, just go to pub.dev. Now that we have our dependencies, we will just create a file. Let's call it .env. Inside this file, we will be placing some important keys and project IDs. So in here, I will be placing my MetaMask, wallet address, and my private key. Also, we will go back to Infura, into our settings, make sure you have Ring-B selected, and we will copy our project ID and our project secret key and just put them in our .env file. I will also save here the address of the contract. And where can I get this address? Let's go back to Remix, and in our deploy and run transactions part down here, we will copy this address and I will be pasting it in my .env file. Okay, so we now know where the contract was deployed to. Let's save. What we need to do now is to add this file to our assets, uncomment these lines and just add our .env file here. Save. Also, an important thing is go to git ignore. If you decide to upload the project to GitHub, make sure that you are not sharing your .env file. Another important thing to notice is we will need something to interact with our contract. So let's create an assets folder. Inside this, I'll create a folder for some images that we might use in our app. And inside this assets folder, we will be placing our ABI. What is that ABI? Let's go back to Remix. Now here in Remix, go to the solidity compiler down here. Let's copy this ABI and go back to vscode. Let's create a file abi.json and inside paste the ABI that we copied from Remix. The contract application binary interface is the standard way to interact with contracts in the Ethereum ecosystem, both from outside the blockchain and for contract-to-contract interaction. Let's add that to the pubspec.yaml. I will also add the images. So I think that's it for now. We have everything set up to start working in our front end. And now let's take a look at our smart contract to see what we need in our UI to interact with the smart contract. So in our smart contract we have three functions: the deposit, withdraw and get balance. In our UI we will have a slider to set the amount we want to deposit and withdraw, a refresh button to get the balance, and we will show our balance up here. We'll let the blockchain part aside and concentrate in the UI, just relax a bit. We have, first I'll remove the comments and also the my page widget. I will create a new one from scratch. So let us add a new folder, we'll call it UI. Inside we will put our homepage file. Let's make it a stateful widget. And now let's import it. In our main we have to do two things. Because we are using the .env package, we have to load the file in here. We are making our main asynchronous, so we'll put a future. We'll import the flutter.env package. And also, because we are using Flutter River Pod, we need to wrap our main app in a provider scope widget. Again, in here we have to do this for the .env package and the provider scope, so we can access our providers in all the widget tree. More on that when we get to the blockchain part. Back to our home page. We'll create a scaffold with the title. Let's add the background image to our asset image folder. Then we have to run our pubspec.yaml file. We are using this font family that we have to specify in our assets. So let's do that. Let's remove these comments in fonts. And of course, we will have to create a new folder called fonts, and in there I will be placing the TTF file. I forgot to add the slash after images, so let's save again and let's run the project. And here it is, this outstanding basic dAPP. Let's just add the buttons and the balance information container and the background. That'll be it. So we can move on to the blockchain part. Let's create the body of our scaffold. I added the background with the ETHcoin PNG image. Let's make this constant to see if vscode stops complaining. I will be building a column to create the other widgets, the balance, refresh, slider, etc. So I created a container that will have our balance. I added this card. We have a text widget and two text widgets. This one will be dynamic, so when you connect to the network we will be changing this value, but for now it will stay like this. If you take a look, you will see that the three buttons, the refresh, deposit and withdraw buttons, are very similar. Only the color and the title changes. Can create a widget that we will reuse inside our UI folder. We will create a new file called custom button. Now let's create our custom button. I already have a stateless widget that receives a title that is required, the color also required. The value will be nullable just because I will use this to refresh the balance, so I won't be passing any value, and I will treat this in the container. I'll receive also the color. Let's build our button. So we have a container that is our physical button that is wrapped in a inkwell, so we can have the on-tap parameter available. Also the opacity, if the value is 0, let's put it another way. If the value is different from 0, or the value is null, we will have the button fully visible. If not, we'll have a 40% opacity. So below we have a box decoration where we receive our color, a box shadow. Down here inside the button we'll have the title with the same font we use in the home page. As you can see, let's refresh. I already had the button here, so you can see how it looks like. Now for the slider, we will use a package. In our pubspec.yml file, there's a Syncfusion Flutter sliders package. This is what we will be using. So in our home page, below our custom button, refresh button, let's add the slider. Don't forget to import it, import the package. So it receives a value. Let's set the value to 0 to start. In our widget, create a double variable and initiate it to 0. Now, we will be using a minimum value of 0 and a maximum value of 10 with an interval of 1 with a step of 1.0. Inside here, when we have a value change, we call setState, just we can see that reflected in the UI. So here it is. Our slider button, we can select values from 0 to 10. Let's add the deposit button. It is similar to our refresh. We are only changing the title and the color for now. Now we are adding the withdraw button. Here it is. Now let's paste this around. So in our main axis alignments, we'll add the main axis alignment space around, and for now this is as complex as we need our UI to be. Let's take care of the interaction with the smart contract. For that, I'm inside the lib folder, I'm creating a new folder called models, and inside that folder let's create a eth utils.dart. In here, let's create a class. We will have our HTTP client and Web3 client. To be able to use this, we need to make the imports. Now we have the HTTP client and the Web3 client with the imports ready. One thing we will need inside this class is the contract address, and if you remember, I saved it inside the .env file. So here it is, the address, and I will just use that inside the Ethereum utils. We import the .env package, and we'll just use the first coin contract address. Now we will need to initiate the setup at some point when building our app. Now we have our initial setup function. Notice that we are initiating the HTTP client. We also have this string infura with the project ID. I'm using the exclamation mark. I'm sure that this doesn't result in null. We have the information in the .env file. Also, we are instantiating the if client. Now, this is done when the app is launched. We need to have functions for each of these buttons. So we'll have one for getting the balance, that will be this refresh, for depositing, and for the withdraw. Let's create them. Oh, we have the get balance function, which queries the network, and it won't take any gas fees for that. So I will create a query function. For the deposit and withdraw functions, we'll need a submit function, which will be a general purpose function that sends a transaction, and it will need some gas. So let's create first the query function. Now that we have the query function, notice that we need to get the contract. We will get the deployed contract. We will also receive the function name, and then we will pass the contract and the function name, as well as the arguments or the parameters. In this case, will be none. Now we have the get deployed function, where we are working with the ABI.json. If you remember, we got this from the Remix IDE, and now we are converting it to a string so that we can use it to create our contract. We need to import services.dart, and now we need to check that the contract address is not null. We'll get our contract so we can use it inside the query and get our balance. That is our objective. Now to the withdraw and deposit functions. We have to make a submission. So for this case, I will create a submit function. And in here, we get credentials so we can make the transaction. And we are using the MetaMask private key to sign the transaction, that we also know that is not null. Then we get the deployed contract, our function, because we will have two functions, one deposit and one withdraw. We have to decide which one will be received. And we get the result from this if client when we send the transaction. We use the credential, we call the contract, and we send the contract, the function, and the arguments. The arguments in this case will be the value we decide to input with our slider. This is it for this function. This utils class is ready, but now we will create some kind of bridge between this class and the front end. For this, we will use a provider. In the lib folder, let's create a new folder called providers. Inside that folder, we will have an utils provider. We will be using provider, but I won't talk much about it in this video. I'll just use it, so if you have any information, you can check the docs that are pretty informative. So in this case, we will be using a state notifier. Now we have a state notifier that works with a synchronous value of type integer. This is probably a bit too much for this case, but let's use it anyway. Let's just put our notifier, our provider in here. Now, in the beginning, when we don't have any value, we want it to show some kind of loading information. So that's why we are passing contract state is null. We will be passing this loading. Also, when we are creating this, when we are accessing this class for the first time, we want to make the initial setup and also get the balance. So here we are calling the get balance function inside the ifutils, and we are setting the state to the result. Then we also need a withdraw function and a deposit function. We are calling the ifutils class to make the three basic operations that we need for our app. One important thing to notice is because I had written deposit balance and withdraw balance, and those were not the names of the function in the remix contract, so we can check that in our sets. If we come here, we can see that the function is called withdraw and the other function is called deposit. So we have to be very careful when we pass the function names, because otherwise it will be a bit painful to debug. So now that we have the provider completed, we will go back to the home page and make our buttons work. Because we want to have the balance value appearing here when we make a deposit or a withdraw or we refresh the UI, we'll wrap the text widget with the consumer. We have to import the Flutter riverpod package and also the ifutils provider. And now we have three different scenarios. So if we have data, first we are watching the provider, the ifutils notifier provider, and we are assigning the result to the balance provider. So in here, if we have balance, we will return a text with the balance. If not, if it is loading, we will return a circular progress indicator. If we get an error, we will pass the error. Let me change. We will print the error inside this container, and we'll get a button to retry fetch the balance. So we've taken care of the first card. Next, we want to go to the refresh button, and when we tap it, we will call the get balance function inside the notifier provider. Inside our deposit, we have to do two things just to keep it simple. We don't want the user to deposit 0 first coins, so let's take care of that inside the function body. So if the user tries to make a deposit when the selection value is 0, we will show a dialog box. We will call the insert value function. Let's create it. Let's create it down here. The insert value function returns a show dialog, so returns an alert dialog. So we get the error, a message not allowed. We get the message not allowed. We are setting our text style, content, the content of the dialog box, this text, and we are also providing an elevated button to pop the context. If the value selected is from 1 to 10, we will then call the deposit coin function. We pass the value, the slider value, we convert it to int, and it will receive a receipt that we then use in a dialog box. So we call it with this function show receipt that I'll create down here. So here we have it. Again, this is very similar to the previous dialog box, and in here we will have the deposit or withdraw word. Then we are also receiving the receipt that we will show down here in this text widget, and we provide elevated button so the user can pop the dialog box. Now the last thing is the withdraw button. Also, I forgot to mention that we have to make this function asynchronous because of the deposit coin function being also asynchronous. So in here we will make sure that the user is withdrawing more than 0 first coins. If not, we show the dialog box that we did in the deposit button. If the value is greater than 0, and in this case we also have to check, if the user has sufficient amount of funds to make the withdrawal. He will not withdraw 9 coins if he only has 8, and that is done in our contract. So if you remember, when writing the smart contract and the function withdraw, we use this require to make sure that the balance is bigger than the amount. If we don't get a receipt, we will show it. If we didn't get it, we will show a canceled transaction type of message, and we will have to create a dialog box just for that. So we will add another function. So we add another function called show canceled transaction, another alert dialog where I'm writing the message, are you sure that your balance is enough to allow the transaction? So in this case, because we are not using any type of events, I'm relying only on the fact that the transaction failed and we didn't get any receipt. So we will assume that the withdrawal amount is greater than the balance available. So now let's hot restart the app to see if it works. Custom button and another inside the withdraw custom button, so the receipt is easier to copy and paste in Rinkeby Ether scan. We'll make a deposit of 2 first coins. Now we have the receipt here. Copy. In Rinkeby Ether scan, I will paste the transaction hash, and we already have success. It took 41 seconds. Now we will make a withdrawal of 4 first coins. We have the transaction hash. Let's copy and back to Etherscan, and this was quick. This is how it works. We should notice one important thing. As I said before, we are not using events. So how do we refresh the balance? If we come here to the transactions, we are doing one thing that is not the proper way of solving this. When we deposit a coin, we get the new balance by adding the amount to the previous amount that was saved on the state, and we update the state with the new balance. This is not the balance from the network, from the blockchain. This is the state balance of the provider. We only get the real balance when we press the refresh button, and because this is an asynchronous function and this can take a long time, we have to keep pressing the refresh button to see if the transaction is already completed. And because this is the first step, we are not using any events. In the next one we will be using, and the update of the balance will be automatic. So make sure you like and subscribe and press the bell button so you can be notified when I upload the next project. Thanks for watching.